Welcome to The Explainer. Today we're tackling a really fundamental topic from the ASVAB General Science Test, and that's the states of matter. We're going to get into what they are, how they change, and most importantly, what you need to know for test day.
Okay, so what do they have in common? Well, you probably guessed it, they're all just water, H2O. The only difference is the state they're in. And understanding why they look and feel so different is exactly what we're digging into today. This is a big one for the test, so let's get it right.
All right, here's the game plan for today. We'll start with what is matter, then jump into the three main states, talk about a fourth state called plasma, see how they all change, and wrap up with a really important one, physical versus chemical changes.
Okay, let's kick things off. Section 1. Before we can even begin to talk about the states of matter, we've got to get a handle on what matter itself actually is. So let's break down the building blocks of, well, everything.
So what exactly is matter? The simplest way to think about it is it's all the stuff in the universe, right? Anything that has mass and takes up space. And this stuff is made of these pure fundamental things called elements. Those are the absolute basic building blocks.
And that leads us right into elements. Think of these as the purest ingredients you can have, like hydrogen or oxygen or gold. What makes each one unique? It's that all of its atoms have the exact same number of protons. It's kind of like their atomic fingerprint. It's what defines them.
Okay, so if we zoom in even further, we get to the atom. Now, this is the smallest possible piece of an element that still acts like that element, right? You can't break a gold atom down anymore and still have gold. It's the absolute most basic unit.
Okay, so now we've got our building blocks down. Atoms make up elements, which make up matter. So what happens when these atoms and molecules start hanging out together? Well, how they behave in big groups is what gives us the three main states of matter we see all the time: solids, liquids, and gases.
First up, let's talk about solids. This is the most rigid, most structured state of matter. Think of an ice cube, a table, a rock. You get the idea.
So, let's look at the properties here. In a solid, the molecules are packed together super tight. They're constricted, they can't really move around, they just kind of vibrate in place. And because of that, solids have a constant volume and a constant shape. They just hold their form, period.
Okay, so what happens when we start adding some energy, let's say some heat, to those tightly packed molecules? Well, things start to loosen up a bit, and that's when we move into our next state, liquids.
And here's the big change you need to see. The molecules in a liquid have enough energy to slide and flow past each other. This is why a liquid doesn't have a constant shape. It'll take the shape of whatever container you pour it into. But, and this is important, the volume is still constant. A gallon of milk is a gallon of milk whether it's in the jug or spilled on the floor.
All right, let's turn up the heat even more. What happens when we give those molecules a ton of energy? Well, they get so excited, they basically break free from each other completely and poof, you've got a gas.
And this is where things get really wild. Gas molecules are flying around so freely and are so far apart, but a gas has no constant shape and no constant volume. It will just expand and expand to fill whatever space it's in, big or small. That's a huge point you gotta remember for the ASVAB.
So solid, liquid, gas. Got it. But wait. There's more. There's actually a fourth state of matter you need to know about. And even though it might sound a little sci-fi, it's actually the most common state of matter in the whole universe. And you don't have to travel to a distant galaxy to find it. Just look up. Our sun is a perfect example. It's just a giant ball of plasma. And this quote here gives you a little taste of the kind of intense heat we're dealing with.
Yeah, that's almost 10,000 degrees Fahrenheit. At temperatures that insane, something really cool happens. The atoms in a gas get hit with so much energy that their electrons are literally ripped off. What you're left with is this supercharged ionized gas. And that's plasma. It's the stuff of stars, of lightning, pretty powerful.
Okay, so we've got our four states down. Now, let's talk about how something actually moves between them. How does that ice cube turn into water? And then into steam?
Well, this whole process has a name. It's called a phase transition. Sounds fancy, but it's really just the official term for when something changes from one state of matter to another. Super simple, right? Like water freezing or boiling.
And really, it all comes down to one thing: energy. Usually we're talking about heat. You add heat and you climb the ladder. Solid melts into a liquid, that liquid boils into a gas. And what happens when you take the heat away? You just go right back down the ladder. Gas condenses to a liquid, and that liquid freezes into a solid. It's a two-way street, all driven by energy.
Okay, this brings us to our last section, and this is a huge one for the ASVAB. So when that water boils and turns to steam, what kind of change are we looking at? Is it a physical change or is it a chemical change? Knowing the difference is absolutely critical.
And this really breaks it down for us. A physical change just alters the form, not what the thing is. Ice, water, and steam. They look different, but they're all still H2O. But a chemical change, that's when you actually rearrange the molecules to make a totally new substance. Think about iron turning into rust. You don't have iron anymore, you have a brand new thing called iron oxide.
So listen up, this is the bottom line. This is what you have to remember for the test. All those phase transitions we talked about, melting, freezing, boiling, condensing, they are always physical changes. Why? Because the substance itself, like H2O, stays the same. A chemical change makes brand new molecules. If you can remember that, you're going to nail these questions.
All right, to wrap things up, here's a little quiz for you. Think about burning a log in a fireplace. You start with wood, and you end up with ash, smoke, and heat. So is that a physical change or a chemical change? Did you just change its form, or did you create totally new stuff? If you can answer that, you're in great shape for the general science section.